Hey everyone, and welcome. Today, we're diving deep into Azure Kubernetes Service, or AKS, and we're going to become architects. Our mission: to build an unbreachable digital fortress for applications by mastering some key networking patterns. So, you've embraced microservices. They're amazing, right? So flexible, so scalable. But let's be honest, getting them all to talk to each other and the outside world securely, well, that can be a massive headache. Instead of getting tangled in all that complexity, we're going to flip the script. Let's think of ourselves as architects. And today, we're going to design and build a powerful, secure digital fortress around our application, one piece at a time. Here's our game plan for today. We'll start by mapping out the networking maze itself. Then, we'll build the front door for our users. After that, we'll secure all the connections inside the walls, and then build up our defenses. And finally, you'll walk away with a blueprint you can use for your own projects. Okay, first things first. You can't build a fortress without surveying the land, right? So we need to get a clear picture of our application's layout and understand all the moving parts. To make this real, let's work with a simple e-commerce app. We've got our storefront API, which is what our customers see and use. Then, behind the curtain, there's an order service and an inventory service doing the heavy lifting. And of course, the crown jewels, all our data, are kept safe in an Azure SQL database. So here's the million-dollar question. How do all these different pieces talk to each other and to the outside world without it all turning into a chaotic, insecure mess? That is the exact puzzle we are here to solve. All right, now that we have the map of our kingdom, it's time to build the main gate. We need a really smart way to let the good guys in and keep the bad guys out. More specifically, how do we get our storefront API out there on the public internet so users can actually, use it? We can't just throw the doors open for everyone. That's a recipe for disaster. And this is where our ingress controller comes into play. Seriously, think of it as the ultimate smart gatekeeper for our entire fortress. It stands at the front, inspects everyone trying to get in, and then personally escorts them exactly where they're allowed to go and absolutely nowhere else. So let's follow a request on its journey. First, it arrives at a public load balancer. From there, it gets funneled to Azure's application gateway, which is like a high-tech security checkpoint, scanning for threats and handling all the encryption. Only after it's been cleared does our ingress controller step in and route that clean traffic right to our storefront API. It's clean, efficient, and super secure. Okay, so the front door is locked down. Awesome. But what about all the chatter happening inside the fortress walls? Protecting that internal traffic is just as important. Now, this is a classic and super critical scenario. Our inventory service needs constant access to that database, but the very last thing we ever want to do is give our database a public internet address. So, how do we bridge that gap privately? The answer is brilliant. It's called a private endpoint. I want you to picture this as a secret, heavily armored tunnel that we build directly from our service inside our fortress straight to the database. The best part? The traffic inside this tunnel never, ever sees the public internet. It stays completely on the private Microsoft network. And the benefits here are just huge. I mean, first off, your database is completely invisible to the outside world. All the communication is flying across Microsoft's own hyper-secure network. This makes your firewall rules way simpler and gives your security posture a massive upgrade. So we have our gatekeeper at the front and our secret tunnels in the back. Now it's time to build the actual fortress walls and post guards to control who can go where. So yeah, we've got these point-to-point connections sorted. But how do we build the bigger walls inside? How do we enforce rules that say, hey, the order service is allowed to talk to the inventory service, but nothing else is? Let's stick with our fortress analogy. Network security groups, or NSGs, are like your big, strong outer walls. They're great at blocking things based on simple stuff like an address or a port number. But for the really smart security, you need a service mesh. These are like the intelligent guards patrolling inside the walls. They can look at the traffic itself, demand to see ID from both sides with things like mutual TLS, and enforce way more sophisticated rules. All right, we've laid all the bricks, we've dug the tunnels, and we've posted the guards. Let's pull this all together into a final blueprint that's going to help you make the right calls for your own fortress. Okay, think of this as your decision-making cheat sheet. If you have a really simple app and you just need to get it online fast, a public load balancer is the easiest option. But for most real-world web apps, the application gateway is the sweet spot. It gives you high security with things like a web application firewall, And when it comes to protecting that critical back-end data, nothing beats the security of private endpoints. And this might be the most important takeaway of all. There's no single right answer that fits every situation. The best architecture is always a trade-off. You have to find that perfect balance between rock-solid security, how simple the design is, and how much effort it's going to take to run it day to day. So, as we wrap this up, I want to leave you with one question to think about for your own work. Take a hard look at your network architecture. Have you truly built a layered, deep digital fortress? Or have you just put up a simple fence? Thanks so much for tuning in.